We're going to do questions 7 through 13 from the mock EOC study guide. Okay, so looking at this first question, number 7, it says solve the equation. We're given 2x squared minus 2x equals 12. Well, I know that in order to solve this equation, I need to move that 12 to the other side of the equal sign. In order to move that 12, I'm going to use my inverse operation. So it's a positive 12, so I'm going to subtract 12 from both sides. And then I get 2x squared minus 2x minus 12. And that's equal to 0. Now looking at this equation, 2x squared minus 2x minus 12, I notice there's a GCF. So I'm going to factor out a GCF of 2, and then I'm left with x squared minus x minus 6. And that is equal to 0. Now that I've taken out my GCF of 2, now I can factor this quadratic function using factoring. I could use the quadratic formula if I wanted to. However, I preferred to try factoring first because I just find that method easier. So my a is equal to 1 x squared, and I'm just putting that 1 there so you don't forget about it. My b is equal to a negative 1, and my c is equal to a negative 6. Okay? So remember, when I try to factor this quadratic function, I'm going to take my a and multiply by my c and get negative 6x squared. And in the bottom, I put my b term, which is just a negative x. Now I need to find the factors of negative 6 that are going to multiply together to give me a negative 6 and add together to give me a negative 1. So the factors of 6 are 1 and 6 and 2 and 3. Now because my 6 is negative and my b term is negative, I'm going to apply that negative sign here on the right side of my table because that's the larger numbers. And if my b term is negative, I know the larger number of my factors is also going to be negative. Then I just need to add these numbers together and see which one gives me a negative 1. Well, 1 plus a negative 6 is negative 5. 2 plus a negative 3 is equal to a negative 1. So my solutions here are 2x and a negative 3x. So we have a positive 2x and a negative 3x. They multiply together to give me negative 6x squared, add together to give me a negative x. Now I'm going to use my area model to find my factors. Now when plugging in my area model, remember we're going to just put our x squared, our a term, and our c term, negative 6. And then these two numbers, our factors, we can list right here. So we're going to have a positive 2x and a negative 3x. Now we just need to factor. So x squared and negative 3x, I can factor out an x. Positive 2x and a negative 6, I can factor out a positive 2. X squared and a positive 2x, I can factor out an x. Negative 3x and negative 6, I factor out a negative 3. Remember, you always factor, take out that negative if it's on the outside of your area model. So my factors are x plus 2 and x minus 3. Now I'm going to set those both equal to 0, and I find that x is equal to negative 2 and x is equal to a positive 3. And those are the two solutions to the equation 2x squared minus 2x equals 12. All right, let's move on to question number 8. 8 is similar to 7, except for now we are just factoring this expression. We are not solving it because there is not an equal sign. So we can't solve this equation because it's not set equal to 0. All we have to do is factor. So 6x squared plus 21x plus 9. First, I notice that there is a GCF, a greatest common factor. My GCF here is going to be 3. So if I divide 6 by 3, divide 21 by 3, and divide 9 by 3, what do I get? So I would get 2x squared plus 7x, because 21 divided by 3 is 7, and 9 divided by 3 is 3. So I have 2x squared plus 7x plus 3. Now I need to factor this expression completely. So I'm going to take my a term, which is 2x squared, my b term, which is 7x, and my c term, which is 3. And I'm going to do just what I did before. I'm going to take that a times that c, and I'm going to get 6x squared, and this is positive. And that b term is 7x. Now I need to find the factors of a positive 6 that will add together to give me a positive 7. So again, the factors of 6 are 1 and 6, and 2 and 3. Everything here is positive this time. So I'm just going to add those together and not worry about any negative signs. And I find that 6 times 1 are my factors that add together to give me 7x. So I'm going to have x, and I'm going to have a positive 6x. Now I can use my area model. And again, in that first box is going to be my a term, which is 2x squared. In this bottom right-hand box, I'm going to have that c term, which is a positive 3. In the other two boxes, I am going to list my positive x and my positive 6x. Now I can start to factor. 2x squared and a positive 6x, what they have in common that I can factor out is a positive 2x. X plus 3, the only thing they have in common is a 1. So I'm going to factor out a positive 1. 2x squared plus x, I can factor out an x. And a positive 6x and a positive 3, I can factor out a positive 3. Now I can go ahead and check my work. Does 2x times x equal x squared? 2x squared? Yes. X times 1, does that equal x? Yes. 2x times 3, does that equal 6x? Yes. And 3 times 1 equals 3. So I can now completely factor this equation, and I'm not going to forget about this 3, my GCF over here, when I list out my factors. So it's going to be 3 times 2x plus 1 multiplied by x plus 3. And that is my final answer for question 8. All right, question 9. The graph of the function f of x is equal to 4 to the power of x is transformed, resulting in the graph of g of x equals f of x minus 6. Which of the following describes that transformation? Okay, so this is from section 3, topic 10. And what we need to remember from section 3, topic 10 with transformations is that if we affect the x, meaning if we have f of x plus any number, that's going to be shifted. Oops. That's going to shift to the, and I'm running out of space, sorry. Let me rewrite that. So if we have f of x plus a number, that means we are going to shift left a units. Okay, so if we add, we shift left. If we subtract, so if we have f of x minus a number, then we shift right a units. So if we are subtracting a, then we are going to shift to the right a. Okay, remember that when we learned this, we talked about it going the opposite direction of what we think. Sorry about that. So it's the opposite of what we think if it's inside the parentheses. Now, if we had f of x plus a outside of the parentheses, then that means that we would have a shift up a units. And if we had f of x minus a outside of the parentheses, then we would shift down a units. The key here to look at is if that a is either inside or outside. If it's outside the parentheses, it's going up and down. If it's inside the parentheses, it's going left and right. All right, so this particular function that they gave us in this problem is f of x minus 6. So if I'm subtracting a number, I'm going to shift to the right that number. So the correct answer here would be the graph f of x shifts right 6 units, because that negative sign is inside the parentheses, so it's going to be the opposite of what I would think, and it's moving to the 6 units to the right. So the correct answer here is C. Okay, moving on to number 10. For some function, f of x, the amount a population of a town grows in thousands is dependent on the number of years since 2000. Which of the following describes what f of 10 represents? Okay, remember, first of all, I want to highlight dependent. It's dependent on the number of years since 2000. Okay? And this number here, the 10, is talking about our independent variable. So this is our input, and dependent is our output. So which of the following describes what f of 10 represents? So what is it representing? They didn't even give us the function. They just want us to tell us what it represents. Well, if they're telling me that they want to know what f of 10 is the number of years since 2000. So the amount the town has grown in the year 2010 with option A. B, the amount the town has grown in 2000. Well, they're comparing it to the year 2000, so that's definitely not the answer. The number of people added to the town in 10 years. Well, that's talking about the output. and it's talking about the number of people added to the town in 10 years. But that's not what f of 10 represents. And then D, the number of people that moved out of the town in 10 years. That's definitely not it, because that would be a decrease. So we're between the amount the town has grown in the year 2010 or the number of people added to the town in 10 years. Well, the number of people added to the town is not what the function is representing. Even though it does sound like it's telling me the output, I don't think that is your best answer choice here. I think your best answer choice here is going to be A, the amount the town has grown in the year 2010. Because if they're telling me that input is 10, they just want me to add 10 to 2000, and that is equal to 2010. All right, moving on to question 11. The points on the graph show the cost of tickets C of T in dollars and the number of tickets purchased T. What is the domain of the function C of T? Well, domain, we remember, is equal to our possible X values, our inputs. So if we're talking about domains, we are talking about these possible numbers. Now, when we list a domain, we can either list it as T, because that's the number of tickets, is greater than 0. Well, T would definitely be greater than 0. But look at here. We have a point at 0. We have a point at 1, a point at 2, 3, and 4. Okay, so our possible X values here are just 0, 1, 2, 3, 4. We don't even have a 5. So our best answer choice is going to be D. The reason it is not all real numbers is because all real numbers would have to include both your negative numbers and your positive numbers, and you can't sell a negative number of tickets. It's not between 0 and 4 because you can't sell 1/2 tickets. And it's not just greater than or equal to 0 because that would also include numbers between 0 and 1 or 1 and 2. And you cannot sell half of a ticket or a third of a ticket. So this is what you would call a discrete function. So your domain is only going to be a certain number of values, in this case 0, 1, 2, 3, and 4, because that's what's indicated on our graph. So that those are the only possible numbers for our domain. Okay, question 12. Consider the graph of the function shown below. Which statements about the graph are true? This is something that we just covered before spring break, so I'm hoping that this is pretty easy for all of you and we get this all correct. So which statements are true about this graph? The graph has a 0 of -3. Well, zeros, remember, are these 2 points. These are my zeros. And I have a 0 of 3, 0 when my y is 0. And I have a 0 of -1, 0. But I do not have a graph, a 0 of -3. So that is not an answer. The graph has zeros, -1 and 2. That is also not a correct answer choice. The graph has a y-intercept of 0, -3. Well, my y-intercept is always when my x is 0, and it does cross the y-axis at -3. So yes, this is the correct answer. The graph has y-intercepts of -1 and 2. No. For a parabola, you can only have one y-intercept. The graph has a minimum point of 1, -4. Well, minimum is when my graph opens up. This graph does open up, and that minimum point is at 1, -4. So yes, that is also a correct answer. The graph has a maximum point of 1, -4. Well, no, if my parabola is opening up, I do not have a maximum point. The graph's line of symmetry is the y-axis. Well, the y-axis is right here. My axis of symmetry is always at the vertex. So this would be incorrect because my axis of symmetry is when x is equal to 1. The graph represents the function f of x equals x squared minus 2x minus 3. Well, I have to look at two things here. X squared minus 2x minus 3. If my a term is positive, that parabola is going to open up. Positive, I open up. And here I have a negative, so I open down. So right away, if I notice that my a term is negative and I have a parabola that's opening up, then I can cross that one out. But that doesn't make h necessarily true. I also need to compare it to my y-intercept. Well, my y-intercept here is -3. My y-intercept on the graph is also -3, so that checks out. The last thing I can check is my axis of symmetry. Remember, the formula to find your axis of symmetry is -b, so a -2 divided by 2 times 1. Well, that is going to be 2 divided by 2, which is equal to 1. So x is equal to 1. Well, we already determined that the axis of symmetry is x is equal to 1. So it checks off 3 points. I can assume that this function does represent this parabola. So that is my third true statement for this graph.